welcome back to the Tech Talks Daily Podcast, a place where I interview tech leaders, CEOs, entrepreneurs, futurists, technologists, thought leaders, and even the occasional celebrity about how they are leveraging technology to transform their business. And today, I'm excited to tell you that Lama Nachman, Director of Human and AI Systems Research Lab at Intel Corporation, is going to be joining me on the podcast. Because at a time where thousands of companies are using systems enhanced with Intel AI technology, I invited her on here today to talk about Intel's approach to responsible AI product reviews. Diversity, equity and inclusion, plus AI intersection, privacy, security and cross-sector partnerships, and what all that means. And she will also highlight some of the AI projects that will show this approach in action and the importance of ethical and human rights implications associated with the development of emerging technologies. And I think this is especially true with the development of AI technology. And I want to learn more about how Intel are committed to evolving best methods, principles and tools to ensure responsible practices in their product development and deployment. Because I think it's so refreshing to hear that we're moving away from that, hey, let's move fast and break things, and adopting a more cautious approach with this sophisticated technology. Quick reminder that this podcast is brought to you by Flipper, the #1 marketplace to buy and sell online businesses and startups. So the question I'm going to ask you before I go is, do you own or run an online business? And have you ever considered selling your site, your store, your tech or your app? Well, with world-class combined matching technology, dedicated brokers and end-to-end services, all at the most efficient price, Flipper is making selling your online business simple. So to get a free valuation for your business, simply visit flipper.com/techtalks, where each month thousands of online business owners are exiting with Flipper. Again, to learn more, visit flipper.com/techtalks. So buckle up and hold on tight as I beam your ears all the way to the US, where today's guest is waiting to talk about how Intel is committed to advancing AI technology responsibly and much more. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Yeah, so my name is Lama Nachman. I'm a Palestinian, born and raised in Kuwait. And I actually came to the US when I was 17 to do both my undergraduate and graduate work in computer engineering at UW-Madison. Today, I'm an Intel Fellow at Intel Labs, and I lead a multidisciplinary research lab of social scientists, designers, and AI researchers that are really focused on amplifying human potential with AI. I also lead, as an Intel Fellow, we also lead these other efforts across the company, and I lead the Responsible AI program and the Responsible AI Advisory Council across Intel, which we started back in 2017 to ensure that all the AI that we're developing at Intel, we're actually developing responsibly.
Fantastic. And we do have a bit of a tradition on this podcast where I always ask my guests to share their origin story. So if I was to take you back in time for a moment, can you remember where your passion for technology came from, or the moment that would ultimately put you on this path you're on today?
So that's a good question. Actually, as I was growing up, even at really a young age, I was always very interested in technology and how it can be improved to actually support like what people need, right? So in a sense, I would say, as a tech user, I was always frustrated by how dumb technology has been throughout my life, right? I was like, if they would only just change the features of this thing to do X, Y, and Z. And I had this kind of like vision of, can technology really understand people and adapt and personalize to their needs? Now, interestingly, when I went to college, right, at that time, right, that was in 87 actually that I went to college. And I knew that I liked technology as a user. I loved math and science. So I just said, okay, well, what's a typical pick? It's electrical engineering. But in my second year in college, I took my first class in computer engineering, which was actually logic design. And I absolutely fell in love with the potential of computing, that it can actually totally change every single field. I mean, to me, this notion of, oh, I can go figure out how to build a computer, right? Program it to do whatever it is that I wanted to do was just so fascinating and empowering. And in some sense, that I would say the first step that got me on this career, right? Then I went on to Intel, worked on computer architecture and how to actually develop these CPUs, and then went on and to startups and specifically focused on ubiquitous computing and sensing and making sense out of data. And frankly, in the last 20 years, really my whole work has been around, context awareness computing, human-centered AI. How do you utilize all of these signals in the world to help make technology more capable of supporting human needs?
And of course, that path would lead you to Intel. And if I was to ask everyone listening on this podcast what Intel means to them, I suspect I would get many different answers, because it has been a part of our lives for so many years. And not necessarily people would automatically say AI, artificial intelligence. So can you tell me more about how thousands of companies are using systems enhanced with Intel's AI technology, and maybe share a few use cases that just help people understand the value that artificial intelligence is delivering to businesses? Because in some areas, it has been accused of being overhyped in previous years. I think that's changing now, especially with things like ChatGPT is making it easier for people to see how valuable it can be. But is there anything you can share with us around that?
Yeah, sure. So starting with what really attracted me to Intel, it was really that, right? It's actually its impact on the world because of the ubiquity of the microprocessor and Intel's relentless commitment to push the edge on scaling compute, right? So, I remember even back in the 80s, right? When I was in college, I would hear things like, Moore's law is running out of steam. We're going to hit a wall. And Intel continued to find solutions to scale computing. Now, if you think about the center of AI, and really what made AI transform so many different fields today, right? And why we're, went out of the AI winter into the blossoming of AI today, really compute was at the center of this, right? So there was compute, there was advancement in algorithms, and there was access to data. So at the center of the AI computing, if you think about all of these Xeons in all of these data centers that are running all sorts of workloads in the cloud, right? From healthcare to financial services, fraud detection, social media, all of these applications today rely on AI to actually be on AI at scale, right? To be able to actually provide these capabilities to the billions of people around the world. And that level of scale is actually quite amazing. And to me, this is that impact. If I can make an impact there, I can make an impact that actually goes all over the world. Maybe another piece that people are not necessarily as aware of, right? Intel, other than just, providing basic capabilities and basic compute platforms that run most of the AI workloads today, we also work on, collaborate with customers to go and come up with specialized solutions, AI solutions in all sorts of different areas, like industrial solutions come to mind, and manufacturing, right? Where we really need to be able to get to better outcomes, reduce errors, provide solutions that can actually target the specific areas that we're going after in the industrial world. That requires a lot of innovation in that space and optimization of these solutions. One last example that I would give you is actually Mobileye, right? So, and I don't know if your listeners are familiar with Mobileye, but, Mobileye actually is, providing AI-based driver assist technology that shows up in hundreds of millions of cars today, right? And that not only depends on processing and process elements that actually allow for that to happen efficiently on the edge, but it also requires a lot of algorithmic innovation to bring AI to actually, enable assisted driving, which is something that, many people today interact with. So I would say what's interesting about it is actually the different layers that Intel come into the table, all the way from the bottom of the stack, which is, basic compute capability and pushing the edge there, all the way to things that actually, people interact with on a daily basis in terms of applications and solutions.
And I think when it comes to technologies such as AI, the phrase "with great power comes great responsibility" springs to mind. And I think the world of tech has moved away from moving fast and break things, and is a much more cautious approach now. And on that side of things, corporate responsibility around AI has become such a big topic right now. So can you tell me more about Intel's Responsible AI Advisory Council?
Sure. So maybe I'll start from where it came from, right? The setup was actually perfect, right? So, I mean, I think, after this, from like 2010, I would say, to 2015, we were all like excited about what AI can bring to the table, right? And we've seen the innovation. We've seen companies at the forefront of, taking AI and bringing it to all sorts of important applications that are really kind of changing the way that we live and work and all of that. Then we started to see some of the concern come up, right? Running at speed, we started to see concerns around privacy and human rights and bias in these technologies and lack of transparency and all sorts of these problems. So as we started to see some of these signs, we actually at Intel, we kind of came together in a small team and we started to look at, well, what does that mean, right? And what does that mean for Intel? Like, what do we need to do to ensure that AI is being developed responsibly in the context of this like vast ways that Intel comes to the table, right? Which isn't necessarily just in a single way. So we actually worked on putting together what we call a responsible AI framework, where at the center of that is actually governance of AI, right? And that means, part of that is putting this responsible AI council, which is really a multidisciplinary team that brings together everything from like social science, ethics, data science, AI, legal, etc., together, and with people across different races and genders and so on, to really bring that holistic approach to think through the different projects across the country. So basically, what the Responsible AI Council does is, at first, it puts together this assessment process that gets applied to any project that has some sort of a human impact with AI. And really what we're asking people to do is think through what are the risks in the context of their specific project that, across these areas of things like privacy, bias, transparency, safety and security, etc. And then as you think of these risks in that context, you think about then what are the risk mitigation strategies? Is that something we should do? And if we should do it, how do we mitigate that risk? And then we engage with them in that inquiry process. So we look at their assessment. Most of the time, we're looking at this and we're saying, okay, well, you missed these risks. And here are some suggestions on what you could do with risk mitigation. Or, really, this project shouldn't be done in the first place because the risk outweighs the reward. So that's really how we kind of do it. And to me, the key piece about the multidisciplinary aspect and really the diversity of the council is that, even us years after we started this process, when we look at something, each person brings a unique perspective to the table, right? So it's like, somebody would raise something that I wouldn't think about at all, right? And vice versa. And it's like, it's that power of diversity that gives us these different lenses that allows us to essentially almost like predict what could happen in the future if we were to do this in the way that we're doing it. And that, I think, is the power of, kind of to your point, slowing down the process a bit and thinking through these ramifications.
And before you came on the podcast today, I was doing a little research and I was reading how Project Amber is a new Intel technology providing organizations with remote verification of trustworthiness in the cloud, edge, and on-premises environments. Can you expand on this? Because again, sounds incredibly exciting.
Sure. So let me maybe step back for a second and say, what is it trying to do, right? What is confidential computing? So if you think about it, right? I mean, today we have our data and code that runs somewhere on some infrastructure in the cloud, right? And the problem that we're really trying to solve is that, people need to be ensured that their data and their code is not being compromised when it's actually running in the cloud. Now, today, if you think about like over time, what we've been able to do is to ensure, okay, well, when data and code is being transported, and being stored somewhere, we're ensuring that it's secured by, virtue of encryption and so on. But what happens when it's actually running, right? When it's in memory? in the infrastructure, right, being computed on, it's in the clear. So that's a problem, right? It needs to be in the clear when you're actually computing on it. So that's a problem because that is a place where it can get compromised, right? So trusted execution environments, an example of that is SGX, is really a platform capability that within the platform, you're ensuring that when you're running within that trusted environment, this data and code isn't being compromised. Now, the issue is, so your code, when it's in that trusted environment, it knows that it can unencrypt itself and run what it needs to run, re-encrypt itself, and then go on. The problem is, how do you ensure that that trusted environment is actually genuine and can be trusted? That's really what Project Amber is about, and that's what we call attestation service. So the attestation service is basically saying this trusted environment can indeed be trusted, it's genuine, and here's how I verified that it's genuine, right? That's the whole point of an attestation service. Now, today, in the infrastructure, if you go to the cloud or whatever, the attestation service is being provided by the infrastructure provider. So in some sense, your infrastructure provider or your cloud provider is saying, yes, here's the infrastructure, you can run it, and I can attest that it's actually, that trusted environment is indeed can be trusted. But that's a problem, right? Because if you essentially have what can be compromised is if you have administrators that are rogue, right? Or other actors within that environment can actually compromise it. So you don't want the same provider to both attest and provide the infrastructure. So Project Amber is a third-party attestation service that basically says, yes, that infrastructure that you're trying to run on and that trusted execution environment can indeed be trusted. And this is really a very hard thing to implement, but also it's not just hard because you need to ensure that you need to understand really the platform and all of the certificates and everything else that's running, but you also need to do it without an impact to performance because it's in the critical data path now, right? So being able to do it at scale is really what's extremely complex about it. And that's really what Project Amber is. It's that third-party service that Intel is providing and other people can provide as well to attest that that trusted environment is indeed trusted.
And what also caught my attention was I was reading how Intel has been exploring deepfake detection and saw that Intel has released this FakeCatcher technology. For anyone listening, can you tell them what FakeCatcher is and maybe give an example of how it has helped detect a deepfake in real life? Because again, this is a big topic right now, isn't it?
Exactly. So again, maybe let me step back for a second and explain what how deepfakes, really work and what we're trying to do around them. So we're all excited about the capability of AI and generative AI. I mean, you mentioned ChatGPT in the beginning, right? Yeah. And, diffusion models. And there's so much amazing innovation today in generative AI, right? And that results in, things that you can generate that are totally unreal, right? And in many cases, there are great uses of that. And we're seeing many of those great uses of that. The problem is when you're actually, bringing that deepfake to actually, in some sense, misinform or pretend like somebody is saying something, when they're really not saying it. And we've seen that with celebrities and presidents and all sorts of people, really having generated content that's totally unreal that fools the human eye, right? Because and this will only continue to get worse over time, right? Because the fidelity and the artifacts of this generated content is really getting much, much, much better. So the problem, you're fooling the human eye. So what we're trying to do or in general, deep fake detectors, what they're trying to do is actually detect different patterns and, artifacts and things like that within the generated content that says, there's something, even if the human eye can't see that, a machine learning model can detect that there's something off here. FakeCatcher specifically tries to utilize other signals that typically are not seen by the human. So for example, we know that we can detect heart rate of people from their faces, right? From just the video of their face, you can actually detect heart rate through, PPG. So what this really tries to do is says, okay, well, I'm going to go and create a spatial temporal map from the face, detect the heart rate from many different points in the face, and then train, machine learning algorithms that say, if this was actually genuine content, what would that look like? What this pattern looks like, right? The thing with, fake content while it's meant to actually fool the human eye, to try to replicate what human heart rate looks like across these different parts, in the face over time, looks like, that's very hard to make genuine. So essentially what you're doing is you're utilizing that signal as an authenticity signal to say, wait, there's something off here that doesn't look like what a normal heart rate would look like if this was actually genuine content. Now, the other hard part of this, and that's part of that solution that Intel put out, is typically this is very computationally intensive, right? So you would upload the video, you would wait for a long time before it came back and said, oh, this is fake or not. What FakeCatcher today is able to do is actually do this in real time. So as you're playing the video, you can actually tell right away whether it's genuine or not. It can come up with a prediction. And it utilizes a lot of the acceleration capabilities within Intel CPUs to do that. An example is actually, I was talking to the researcher who's actually in my team who's working on this. And there was a video of Zelensky, the Ukraine president, that was actually, spreading misinformation about the invasion. And what they did is, so she ran it on that content. And the result of FakeCatcher basically said, there's 93% confidence that this is a fake video. Then she took some video of Zelensky from Reuters that's been verified, and she ran it. And it basically gave her higher than 95% confidence that this is actually genuine video.
Wow. How cool is that? That's incredible, isn't it, to do it with such accuracy? And when it comes to technology, I often say that we should dare to dream and think bigger when it comes to technology and the possibilities. And with that in mind, can you tell me more about Intel's extended collaboration with Mila, which is, I believe, an AI research institute that helps advance AI techniques to tackle global challenges? We're talking big things here again: climate change, identifying drivers of diseases, and expedite drug discovery, etc. Because again, feels like a bit of a game changer moment in the next few years.
Totally. And I think that goes back to, what we started the conversation with, which is really the potential of AI to really almost transform every single field that it intersects with. So in September, Intel and Mila, yes, it's an artificial intelligence research institute, which is based on Montreal. We announced a 3-year strategic research collaboration with them. And it has about, 20 or so researchers across Intel and Mila. And they are focused on advancing AI techniques and capabilities so that it can really tackle the challenges that you mentioned about climate change, new material discovery, study of molecular drivers for disease and drug discovery. So let me maybe give an example, because sounds like, what does that really mean, right? So let's take climate change as an example, right? So today we have standard physics-based climate models that actually can do, climate modeling. The problem is they're very complex and they're extremely computationally expensive. And it takes months to run these on actually specialized supercomputing hardware, right? So what does that mean? The problem with that is that then you could say you can't run this as frequently as you need because it takes forever to run. And you can't run it at the fine-grained level that you need. You can't really do a lot of localized prediction. You can run overall general models, right? Because of that compute barrier. So what we have seen with AI, and an area that AI has done really well in, is essentially taking a lot of these, standard models and, physics-based models, and then using that to generate a lot of data, and then train machine learning models that are much more computationally efficient to run these. So then you can run the predictions through the surrogate machine learning model that's trying to mimic that extremely compute-intensive, physics-based model. Now, the problem is, this is all great, and we do it in many places. But the problem, when you look at climate science, right, how are climate scientists going to actually trust the outcomes of these models or even understand what their impactors are, right? Because the thing about the machine learning models, it's going to take all of this data, it's going to spit out something. But how do you understand the inner workings of it, which you would have in a standard physics-based model, right? So the whole area of research is what we call causal ML, right? Which is essentially what you're doing is you're building these ML models that are able to identify or explain better what is happening and identify which of these variables and, highly dimensional inputs, right? Gazillion inputs that are going into this process, which of those are the ones that are predictive in that specific prediction that you have? So you can actually have traceability and a better understanding of the inner workings of these models. And that, advancing causal ML, right? I mean, a focus on climate change is fantastic, but you could imagine how it advanced many different areas, right? Not just necessarily climate change, but in some sense, by actually solving the basic AI capability needs around causal ML, right, you're really enabling that, many of those applications to happen. And the focus here is on climate science because it's an extremely important problem and one that cannot really be solved in other ways.
I know that Intel is committed to advancing AI technology responsibly. And just to bring some of this to life that we're talking about here, do you have any examples you could possibly walk me through to help any business leaders understanding how a multidisciplinary review process throughout the entire development lifecycle work and the kind of difference that ultimately it makes in the long term?
Totally. So I started talking about this whole, multidisciplinary responsible AI council and this notion of, ethical impact assessment. So basically, if you think about the life cycle of an AI project, right? Initially, what you're doing is you're trying to understand, okay, what is it going to do, right? What is the function? And you design essentially the overall function of this thing. Like, what is it going to do? What problem is it going to solve? How, is it going to solve it, etc. Even in the early stages of that process, doing this assessment from the lenses that I talked about, right, in terms of privacy, human rights, transparency, et cetera, all of these angles that I mentioned, doing that assessment of the function itself, right? Am I going to expose people in the wrong way? Is this going to violate people's privacy? Could this be misused, to violate human rights, right? So all of these assessments happen really early in the process to understand whether we should build something in the first place or should it have these features that we're talking about. Then as you move into the development part of this thing, right, you could have something that's absolutely fine building out, but the way that so take FakeCatcher, I just mentioned FakeCatcher as an example, right? It's a fantastic capability. It solves a lot of problems. Now imagine a FakeCatcher that doesn't really work well, depending on, for example, the skin tone, right? I mean, you're trying to analyze PPG signals, right? How do you ensure that? Because a lot of times, basically what we do is we look at the accuracy of something and we say, okay, well, the average accuracy is this. Great. Now we can put it in the world. But if you actually start to look at the breakdown of that accuracy, what does the accuracy look like for people of color? What does it look like for people of different genders? And you start to do that analysis a lot of times. And, we've seen that, for example, early on in face detection as an example, right? Where people of color were having things like, 20 and 30% accuracy of detection, whereas, white people were actually getting 90+% accuracy. And it was averaging to something was okay, but the discrepancy in that fidelity of recognition was quite different. So that's what we call a bias problem. And that means, the data sets that you use need to be balanced. The way that you do the quantitative analysis to ensure that you don't have that type of discrepancy need to happen in the development process, right? And that's an example. But also you could see when you go into the deployment part of this, not just the definition and the development, but even the deployment, there can be quite a bit of risks in the way that it's deployed and where it's deployed and who is deploying it, right? Are you actually giving this capability, even though you had an intended use? Would this be misused? A lot of that has to do with who is actually taking on this technology to actually deploy it in the world, and how can you ensure governance in that this is not being used to violate human rights down the chain. And it's something that we actually track and understand where the high risk is, and would cease to sell products to customers who actually would use it to violate human rights. So it's really a whole from start to finish, right? From the initial phase to all the way to the deployment, you really have to be thinking through these risks.
And of course, if anyone spends any amount of time doom scrolling down their news feeds, they will see a lot of doom and gloom that often surrounds new and emerging technologies. And I'd love to restore the balance a little bit here in the universe and ask you, what excites you about leveraging technology to tackle some of the challenges that the world faces today, and also drive tangible results for businesses? Because this is where the magic happens, right?
Yeah, exactly. And, I would say, honestly, I started by saying that I think generally, if you think about AI, the potential, we haven't even scratched the surface on the potential in truly revolutionizing every single field. I mean, we talked about Mila and these areas, which I'm extremely excited about, right? I mean, those are things that are really global challenges that will change the world as we see it. And just trying to advance the technology in these fields independently isn't going to get us there. I am very excited about actually health and personalized medicine and trying to go beyond the notion of what works for the 80% of the population to really personalizing to the genetics and the environment of a single person. We do a lot of work within Intel on what we call AIification in manufacturing. And how do you bring AI to help support humans in decision making and in debugging and in trying to essentially improve things like yield and design and all of that. And in all of these areas, AI has been really transforming the way that we do work every single day. So I'll go back to what I said in the beginning around really my passion is about AI amplifying human potential. And, we've seen that and advanced research and things like how do we help children learn, especially early childhood learning in a personalized way. And how do we support people in assistive computing, right, with people with disabilities to be able to actually live their life independently. And that's where we've really, in these three areas that I mentioned, we've really focused a lot of the research within my team. And that's a lot of my excitement. Like AI should come in and help amplify human potential and support human need.
Absolutely love that. And we started the podcast talking about your origin story and what put you on this path and talked about your extremely successful career. But of course, none of us are able to achieve any amount of success without a little help along the way. So if I was to say, is that a particular person that you're grateful towards who might have seen something in you, invested their time in you, or just helped you get you where you are today, probably without even realizing it? Who would that person be? And is there anyone you'd like to thank?
Yeah, so I'm extremely grateful for my dad, who I would say, without him, I definitely would not be here today. So just picture this, right? A girl growing up in Kuwait in the 70s and 80s, in a place that really there's no gender equality whatsoever.
Yeah.
And he actually managed to create that bubble for me that actually helped me truly believe that I can achieve anything that I can set my mind to if I'm passionate enough and I'm just, persevering to actually make it happen. And should not be troubled by going against the norms of the society or the people around me. That just because a lot of people think that this is insane, it doesn't mean that it's insane. So if I reflect back now on my career, even starting when leaving Kuwait at the age of 17 to pursue college education on my own in the US, in a field that women even today are not really very present in. I mean, I was at UW-Madison, right? There were so many classes that I was the only woman in those classes, right? Or choosing to just, pursue all of the things that I've pursued in my research, where early on in a lot of these areas, I would talk to people about what it is that I'm doing, and people would be like, well, that makes no sense. Like, why would you actually do that, right? And over time, proving that this is really at the early signs of something that can be really, truly transformational. And, yes, not being afraid to fail, taking on really high risks and coming back and really kind of pivoting towards the right areas that can really advance the technology. I honestly, without, even when I think back at the Stephen Hawking project and everybody telling me like, no, he's very risk averse. He's not going to change something that he's been using. And, within a couple of years, we managed to actually build a solution that he used throughout his life until he passed away. So, if I just literally, there's a trail of innovations over time where it was really against common wisdom that I trace all the way back to being in an environment where I live my life against common wisdom.
Wow, what an incredible story. I absolutely love that. And we've covered so much in a short amount of time today, and I know Intel is a huge website. So if there's anyone listening that would like to find out more information about anything that we talked about today, what would be the best place to point them to?
There is you can find me on LinkedIn. There's also Intel Labs has, a site that actually shows a lot of the innovation that's actually happening within Intel Labs. So I can actually send you this information. The links and so on.
And I'll add those links to the show notes so people can find that nice and easily. And like I said, we've covered a lot today, from Intel AI technology, Intel's Responsible AI Advisory Council, Project Amber, what that entails, and where we're heading to in the future, and all washed down with your inspiring origin story too. So just thank you so much for sharing your story with everyone today.
Thank you. I really enjoyed the conversation.
Wow, what an incredibly cool guest there. We covered so much, didn't we? From Responsible AI Advisory Council, Project Amber, AI for Workforce programs. But artificial intelligence is something that is going to be impacting each and every one of us. For example, I write for a living. The arrival of ChatGPT is certainly interesting. But for me, I don't think it will ever replace the role of a writer, but it will help me work more efficiently and help with brainstorming new ideas. But AI, automation, is very, very real. And when AI starts impacting diversity, equity, inclusion, privacy, security, and so many other areas of our lives, it's so important to advance AI technology, but responsibly. And rather than have that knee-jerk reaction where I've seen a lot on our news feeds where people just say, this is bad, it's going to take over the world, etc. I want to hear some of those stories, but I also want to hear some positive stories too, and how you might be hopeful or even excited about the positive impact that AI will have on society. I want to hear all sides of this story, and if you'd like to come on here, it'd be great to have someone for and someone against, and we can have a sensible conversation together where we highlight everything. Or feel free to just send me a quick message or question, whatever it might be. My email is techblogwriter@outlook.com. You get me on Twitter, LinkedIn, Instagram at Neil C. Hughes. We'll keep this conversation going because I think it is an important one. And if you've got nothing to say today, don't worry. I've got another guest and another topic lined up tomorrow. So I invite you to join me again and we'll explore these topics together. But a big thank you for listening today. And until next time, don't be a stranger.